So, we are going to study auto configuration for IPv6, the full process in depth explained. So, this is not only about auto configuration itself, but all the means for IPv6 to configure a node and to keep this configuration updated over time. And also we will also have an introduction how the configuration is managed when the node is moving. So we will see that with mobile IPv6 it is possible to keep the same configuration anywhere you go. So that's a little bit about myself and where you can meet me on the web, on the blogs, and if you want to write me on email, you're welcome to drop me something and I will answer to you. So again, auto configuration is very important for IPv6. It is not only about getting a network address and a default route, DNS servers, domain name, and any other servers, but it is also about changing your configuration when needed. If, for instance, for privacy, you want to change your address every day, this is something which is possible. Or you may also want to renumber your network if you got a new network address, and this must be managed automatically. Now, for the people who are roaming and moving from, for instance, if you move from home in the morning and then you reach the office, you may not want to have to restart all your applications that you have started in the morning. So you may, for instance, want to log in the morning and don't want to log in and log out again for the rest of the day. So you can keep the same configuration wherever you go, and this is something that you can have if you use mobile IPv6. Auto configuration is a feature which is enabled by default on most platforms. The only exception is about Linux. With Linux, you may have to configure auto configuration, which is not configured by default. In auto configuration, when the interface is starting, the first state is actually a tentative mode. In this mode, the interface is actually verifying a couple of addresses and making sure that the interface can be used for IPv6. So the first step is to check the linked local address, and if the linked local address is verified, then additional addresses may be configured. If the linked local address is not verified because it is a duplicate, for instance, then it will be the interface will not be used by IPv6. The normal state for IPv6 is preferred states. In the preferred state, the address can be used for a new connection or for existing connection. This is a normal state, and as long as your address is refreshed by any means, the address will remain in the preferred state. If the address is not refreshed by a router advertisements or by the IPv6, the address may reach a deprecated state. In the deprecated state, actually, the address should not be used for any new connection. So it is still a valid address, but the address should not be used for any new connection on the nodes. This is very useful for renumbering process. So again, the valid state is the sum of the preferred and deprecated states. So both states made the address valid, which means that this address can be used as long as the valid timer is not expired, as long as the address has been refreshed by any mean. When the address has not been refreshed for too long, then it will eventually reach the state invalid. So when it is invalid, it means that this address actually cannot be used any longer on the interface, and basically it is like if the address is unconfigured from the interface, because it is not possible to use the address any longer. So that's the first step of initialization. Derive the link local address, check if the address is unique by using the duplicate address detection process, which is sending a multicast neighbor solicitation message and to yourself. And so you expect not to receive any neighbor advertisements, because if you do, it means that somebody else is using the same address than you, and then you stop and the address is not initialized. If the link local is not verified, the interface is devalidated, it is deactivated for IPv6. It will not be enabled for IPv6. If the link local address is valid, then it is initialized and we can go to the next level. So again, the first step, initialize and check the link local address, is really the first thing to do. So if this is a capture of a screen capture of this process on a Ubuntu platform, so you can see the neighbor solicitation, which is sent from the unknown address. The source address is the colon, which means that this address has not been initialized, and it is sent to the neighbors, to the multicast address, the neighbor node solicited multicast address, which basically sends the IPv6 solicitation to itself, and it expects no replies. If there is a reply, it means that the address is already used by somebody else. The next step is to send a router solicitation message. When you send a router solicitation, you expect a router to send you a router advertisement, which will allow you to get a lot of configuration and maybe additional prefix. So that's the second step. Issue a router solicitation and expect router advertisements to configure your interface. By the way, it is not a good method to force the use of DHCP to suppress the router advertisements, because actually if the node does not receive a router advertisement, it is going to try DHCP, and that's it. I mean, once it has done this, the auto-configuration process is over. So again, it is not the right way. If you want to also use DHCP, you have some other means, some flags to set, and it will call DHCP. Suppressing the router advertisement is not a way to convert IPv6 to IPv4. And for instance, DHCP-v6 cannot provide a default route. So you really need the router advertisements, and it is not a good method on a LAN to suppress the router advertisements. On Linux, again, it is something you can control whether you want to keep the router advertisements or not. The router advertisements have a lot of information. The router advertisements can, for instance, say if the router must be used as a candidate for a default route. So if this router can be used for your default route, it will depend on the lifetime. If the lifetime is 0, it means that the router cannot be used as a default route. The lifetime only apply for the router as a default route capability. It is not used for anything else than this. The router may have also preferences, low, medium, or high, and it also includes the MAC address, so you don't have to ask the router MAC address when you want to use it. The other important information includes the default hop limit, the MTU, DNS server's address, and if you have also many prefixes which are advertised on the link, it may be also included in the router advertisements. And the last information, very useful, are flags which indicate if a DHCPv6 server is available on the network and must be used by the nodes or not. Be careful, it is easy to craft a router advertisement, and there are some attacks using router advertisements. There is a very nice RFC to read about it, which is RFC 6104, which I recommend to implement security in your network. So that's an example of a router advertisement I captured on my connection to my service provider, who is a dual stack CPE. So you see the router advertisement is sent to the all nodes multicast address. So in this case, the router lifetime is 1,800 seconds, which is how long this router will be considered excuse me, will be considered a default route candidate if no refresh is received. If a refresh is received, then this time will be extended. The reachable time and the retransmit timer are for the neighbor unreachability detection, and 0 does not mean that it must be reset to 0. 0 here means that you do not have to change the default values which are configured on the nodes. This is the unspecified configuration, which means that do not change the configuration which is already done. Then you may have many prefixes. You can see that each prefix has a lifetime, a valid and a preferred, and also two flags, the on-link and autonomous. We will see these flags in detail very soon. We can also advertise the presence and the address of DNS servers, the MTU for the link. So in this case, it is not 1500 because I am using a 6RD service, which means that my IPv6 traffic is tunneled into IPv4. So we need some room for the IPv4 encapsulation. That's what the MTU is not 1500. And at the bottom, you can see the link layer address, which is the MAC address of the router. So next, from the router advertisements, the node is going to check all the received prefixes which may be contained in a router advertisement. And each prefix, if it can be used to derive an address, it must have the on-link and the autonomous flag set. if both flags are set, it means that the prefix can be used to derive an address. So in this case, we derive the stateless prefix and the interface ID. From the prefix and the interface ID, we derive the stateless address, and then we check this address sending a neighbor solicitation message. Again, this is the DAD process, the duplicate address detection process, and again, we don't expect to receive any neighbor advertisement, because if we do receive a neighbor advertisement, it means that somebody else is using the address, and in this case we are not initializing this address. So please note that if the link local is duplicate, the interface is disabled. This is not the case here. If the address is a duplicate, the address is not initialized, and that's it. And we loop as long as we have prefixes, and we check each prefix the same way to verify if the prefix must be used to derive an address. So again, each prefix has 2 bits in the flag, the onlink and the autonomous bits. Basically, both bits must be set if you want the address to be used by stateless address autoconfiguration. And then from this prefix we had the 64-bit interface ID, which can be derived from the MAC address if it is a EUI64 format, or it can be a random number if we use privacy extension, which is recommended actually. And we also have 2 timers, and these timers are used to manage the address and make sure that the address has a finite lifetime. And if the address is not refreshed, then the address can move from a different state, as we have seen. It goes from preferred to deprecated, and then to invalid, and then so the address is deleted. So it is important, these timers are important to make sure that the address must be refreshed using router advertisements or the IPv6 to make sure that the address can still be used. The prefix information can also be configured on Linux if you want to accept this prefix information or not. And again, for each prefix we received in the flags permitted, we derived an address either from the MAC address, either from a random value if we use privacy extension. The last step for the auto-configuration process is to check if some more configuration must be performed using DHCP version 6. So we check 2 flags, the managed address configuration flag and the other configuration flag. So that's the end of the auto-configuration. Basically, the managed address configuration flag is if you want to use the DHCP to configure address and everything. If you want to use the DHCP for anything but address, you must set the other configuration flag only. So if the managed flag is not set, but if the other flag is set, then in this case it means that the DHCP will be used for anything but address. Remember that we still need router advertisements. The DHCP cannot be used alone because some parameters must be passed by the router advertisements, like a default route, for instance. So this is a summary of all the possibility to do auto-configuration in IPv6. So basically we have the stateless address auto-configuration where we don't need a DHCPv6 server. Everything is received from the router advertisements. The duplicate address detection is used to test each new address which we derive, and after the address has been tested, the address can be used. The stateful DHCPv6 configuration, in this case, we use DHCP to configure address and everything. So in this case, the managed flag is set to 1, and usually it is redundant, but we usually also set the other configuration flag to 1. The stateless DHCPv6 configuration is a hybrid solution where we don't want to use DHCP to configure address, so the addresses are derived from the router advertisement prefixes, and the rest of the configuration is actually provided by DHCPv6. So in this case, only address is configured from the router advertisements. I mean, not only, but address are configured by router advertisements, and then we use DHCP to configure servers and maybe a domain name, for instance. Another use of DHCPv6 is prefix delegation. With prefix delegation, DHCP is not used to provide an address, but to provide a block of address. And then this block can be subnetted to configure each interface. So it allows the service provider to allocate a block of address to a customer, and then it is the responsibility of the customer to subnet this block on many interfaces. And you see that in many cases, a CPE can be a DHCP PD client on one side and a DHCP server on the other side. So in this example, this CPE is a PD client on one side to receive the prefix from the ISP, and then it is also a DHCP stateless server to provide the local host with address of DNS servers, for instance. So the CPE requests the prefix is given by the PE, and then the CPE set a flag, the O flag, to tell the host that other configuration must be requested by DHCP, and the CPE is providing the host with the DNS server address. Another example where DHCP can be used for auto-configuration is with 6RD. In 6RD, the residential gateway, the CPE can be configured using DHCP option 212. This is standardized in RFC 5969, and in this case, the residential gateway configuration, the 6RD configuration, is actually provided by DHCP. So once the address is configured, remember that the normal state for an address is the preferred state. So which means that it must be refreshed. It must be refreshed to remain preferred, because it is only in the preferred state that the address can be used for new connection and for existing connection. So we will need router advertisements refreshments, or we will need the DHCP protocol, but one way or the other, either way will be used to refresh the preferred and the valid timer to make sure that the address remains valid. So for the stateless address auto-configuration, you must configure the router consistently with right timers, and for the valid and the preferred timers, you may also configure the flag for DHCP and everything. And then, if everything is okay, the router advertisements will be used to refresh the preferred and the valid timers. So this is normal behavior for workstations. The timers are decremented, and every time a new router advertisement is received, the preferred and the valid timers are reset, and so they are always, the address is always in the preferred state and never reach the deprecated state. So that's a normal behavior, the normal operation. But these timers can also be refreshed by DHCP-v6. So exactly the same timers are present in the DHCP options, exactly the same. And this can be done by any kind of DHCP with prefix delegation as well. We still have this concept of timers, and these timers are refreshed. Here it is with a DHCP renew. The renew is actually to ask the server to keep the prefix allocated for longer. The renumbering also rely on these prefixes. So the renumbering can be done with router advertisements or DHCP-v6. And basically, you will have two prefixes: an old prefix with addresses which will become deprecated. So this address will not be used for new connection, but only existing. All the new connections will be built using the new prefix. The old one is still there for the time that the old sessions are dying, and when the old sessions are dying, they don't use the old deprecated prefix. Only the new prefix is used for new connection. So after some time, all the connections are on the new prefix, and the old prefix is no longer advertised by the router, and the old addresses built from the old prefix just die. So this is how to configure this on a Cisco router. You can set the preferred timer to 0, and if you set the preferred timer to 0, the derived address will immediately reach the deprecated state. Another way to automatically configure and make your life easier is to use Mobile IPv6, because with Mobile IPv6 you can move all day long, but for the application you always use the address that you were using at home. Okay, so without Mobile IPv6, actually, every time you visit a new access network, you get a new address, and because you get a new address, the sockets must be restarted, the applications must be restarted using a new socket. And so you need to log in and again every time you move to a new location. With mobile IPv6, you get a new address, but I mean for the application, it is always the home address which is presented. So for the application level, it is exactly as if the mobile node was never moving from its home network. So there is no, for the applications, the mobile nodes never move from its home link. It is supported basically on Linux, and on Mac OS you can find some KME implementation. On Windows it is really not supported, because the corresponding node mode without route optimization is actually something which is quite transparent, so we cannot say it is supported by Windows. So this is the principle for mobile IPv6. When the mobile node is leaving its home network, it acquires a new care. A new care of address. So it is acquired by stateless address autoconfiguration, or DHCPv6. So the address is just learned by router advertisements. Just exactly the same as we have seen before, so no difference. It is what we call a care of address. Then this care of address is going to be registered with the home agent. The home agent is a function which is running on the home router of the mobile nodes. So basically, the mobile node is sending a binding update to its home agents, saying, hello, I am a mobile node, this is my home address, and now I am moving, and this is where I am now. This is my care of address. So the home agent is going to verify that the node is allowed to do it. It is a permitted node, and if it is accepted, it is going to send a binding acknowledgement. It is going to build a binding table in which it will have a match between the mobile node address at the home network and the care of address. So it will have a binding between the two addresses, and it established a tunnel. And once the tunnel is established, actually, all the traffic will be intercepted by the home agents. So when the mobile node is sending traffic to the corresponding nodes, basically it is encapsulated. Traffic is encapsulated. Traffic is encapsulated, and the external encapsulation is the source address is the care of address, and the destination address is the home agent's IPv6 address. But inside, the encapsulation has the mobile node IPv6 home address, so the address on the home network, and the destination is the corresponding nodes. So when the corresponding node receives the packets, actually the datagram has the mobile node IPv6 home address, just like if the user was still on the home network. So for the application, there is no change. The mobile node is still at home. And when the corresponding node is responding to the mobile nodes, the home agent intercepts the traffic and encapsulates the packets using the care of address as a destination and the home agent as a source. But the packet inside has the source address, which is the corresponding nodes, and the destination address is the mobile node IPv6 home address. So again, for the application, it is again transparent. The packet is sent to the nodes at the address on the home network. So no new session, no new sockets. Everything occurs exactly as if the mobile node was still on the home network. Now, in IPv6, we can do something we could not do in IPv4. It is to build a direct tunnel between the mobile node and the corresponding nodes. So if this is enabled, the mobile node is sending a binding update to the corresponding node directly. And then the corresponding node is going to make a verification that the mobile node is really the mobile node and not somebody else. So to verify its identity, it is going to send packets to the home network address and to the care of address. And the mobile node should be able to receive both packets. The packet sent to the home network and the packet sent to the care of address. So both packets are sent and both packets must be received by the mobile nodes. And if it is the case, then the corresponding node will send the binding acknowledgement, and again a direct tunnel will be established between the mobile node and the corresponding nodes. And now there is no more need for triangular routing. It is possible to send traffic directly between the corresponding node and the mobile nodes. And how it is going to be transparent, because now we don't have the home agents to perform the swapping of addresses. So basically we are using IPv6 extension headers. So when the mobile node sends a packet to the corresponding node, it sets the mobile node IPv6 home address in the destination option. So when the corresponding node is receiving the IPv6 packets, the IPv6 stack takes a look at the destination option and it finds the mobile node IPv6 home address, and it is going to swap the mobile node IPv6 care of address with the mobile node IPv6 home address. And one more time, when the application on the corresponding node is receiving the packet, it is received from the mobile node's home address and not the care of address. And on the other direction, it is also using another option header. This time it is a routing header. So basically, the corresponding node sets the mobile node IPv6 home address in the routing header. So when the mobile node receives the packets, it takes a look at the routing header and swap the destination address with the destination address which is in the routing header. So the application on the mobile nodes again receives the packet which destination is the mobile node IPv6 home address, and again it is again transparent for the application that the mobile node is no longer on its home network address. So that's the base of many applications. Actually, mobile IPv6 is the base for many applications. For mobile phone, a protocol called Proxy Mobile IPv6 is a protocol which permits to offload all the complexity of the signaling and the protection on the network. So the smartphone does not have to deal with the IPsec tunnels and with the mobile IPv6 signaling. The mobile nodes only use neighbor discovery protocol, and then you have two new nodes. So basically the local mobility anchor is the home agent, and the mobile access gateway is going to be the interface between the mobile nodes and the mobile network. And it will translate the neighbor discovery protocol to signaling like binding updates, binding acknowledgement, and everything. The mobile node can also be a mobile router. So if it is a mobile router, it can have many nodes attached to it, and when it is moving, all the nodes which are attached are moving with the mobile router. The mobile router can be a smartphone, for instance, and the nodes can be attached with Wi-Fi or Bluetooth. It can be iPad or a notebook or camera, and wherever you go, your mobile router is moving with you. And again, thanks to mobile IPv6, your laptop will not have to log out and log in again every time you move to a new location. Another application is Manet, the mobile ad hoc networking, which in this case the nodes are discovering the neighbors dynamically, and they are building a network dynamically. So this is a very nice applications because it has many possibility, and it opens many applications actually. So for instance, if the nodes have sensors to measure the temperature or anything, we can imagine any kind of applications, and a new group for the wireless sensors networks has been formed and came up with many protocol to design wireless sensors networks, and there are many applications which all are derived actually from mobile IPv6 and from auto-configuration. So all these applications are possible only because at the beginning IPv6 came with auto-configuration, but auto-configuration, as we have seen, is not only getting the configuration when the node is booting, but it is much more than this. And many applications are possible. So thank you very much for attending. If you want to drop me an email, or if you need any more information, you're welcome to write me. Here is my address, here is my blog. You can also find me on Skype and Twitter. So do not hesitate to drop me a line or to call me. And I hope I talk to you later. Thank you very much. Bye-bye.